way it works with DC is really it's so forgiving. It's remarkable how forgiving this whole setup is. Charging with DC. This Ford G1 alternator, of course, in a car puts out around 16 volts because it's regulated by a regulator. And what I've done here is tap the field, and I have it on a switch, which I will now shut off. And I've run it through a rheostat, which is 12 ohms at 50 watts. And I can vary this rheostat. I've got it wide open right now. In other words, there's no resistance in that rheostat right now. I've got it cranked all the way up. And in this application, I probably don't even need it. But it's there for adjustability. You can vary the current running through the field of that alternator, which will then vary the output, as I showed you I was doing, as I varied the RPMs of the Yanmar. That is a 3-cylinder, 11.2 horsepower Yanmar diesel that was rescued from a retired refrigeration unit that was on a truck. Anyway, back to the point here. This is so forgiving. It's crazy. It was all such a mystery to begin with, and it is no mystery at all now. I am charging a 48 volt battery bank with this truck alternator, and it works just absolutely beautiful. It doesn't get warm. It moves a lot of air. It's got big fins on it that pull a lot of air through the alternator. That thing will sit there at 50 amps all day long, a little over 2,000 watts, and you can lay your hand right on it, and it doesn't even begin to get warm. I should say all day. I haven't had it running all day, but I've had it running for a good hour and a half at full throttle, and it doesn't even get warm. So my point is, if you're trying to charge a battery bank, what will happen is, as soon as you connect your battery bank to that alternator, it will put the alternator basically right at the battery voltage. Whatever your static nominal battery voltage is, and I can show you here real quick. This bank sits at 49.1 volts when it's fully charged, and it'll go down as low as 42 volts before the inverters will shut off the power. So I ran my wires from the alternator in, and you come into your negative side, and you come in here. I'm sorry, this is the negative side, this is the positive side, and you want to come in on the load side of your shunt, and that way you're supplying firstly when you're charging, just like the charge controllers would be doing. You're firstly using the energy being produced by the alternator to supply your inverters, and just like your charge controllers would do, they will come in first into your shunt and into your positive load side and supply your energy needs, and anything that's left over will travel through the shunt, and in this case it's a disconnect, and ultimately onto your batteries. Whatever your battery is, whether it's lead acid or whatever, it'll travel through the shunt and go to your batteries. So back to the DC generator. It wouldn't matter if I had a 12 volt battery pack, 24 volt, like my good friend Stephen Davis has, or 48 volts, or even 60 volts. This alternator will put out over 60 volts. If you spin it up fast, it'll put out 100 volts if you spin it even faster. And it will simply put out whatever current it can based on the field current going into the alternator. And by the way, this is only about 40 watts is what this takes to drive that field. So it's really small potatoes. The idea of playing with a PMA, permanent magnet alternator, so you don't have to, you're saving that 40 volts is just doesn't make sense to me now that I've done it this way. This gives you all the variability and all the adjustability that you'd want. If I want to run the engine faster and I don't want as much output current, I just turn my resistor down. If I want to run the engine slower and I want more output current, I turn my resistor up. Well, actually I lower the resistance, but I turn it all the way up. And it allows you that variability. And Jesus, it works just great. I mean, it works so slick. So now the test is, I've got to determine what the cost per kilowatt hour is using this setup. Cost per kilowatt hour in terms of the cost of the diesel fuel. And I have done it. I have done the same arrangement using this guy. Harbor Freight 6.5 horse Chrysler alternator. I've got this taken apart now because I've used the battery and the components over on the diesel. This is quite an expensive way to generate electricity. This works out to somewhere in the neighborhood of 56 cents, I believe it was, per kilowatt hour. And you can buy electricity for 17 cents. So we want to try and get our generation down in that close to 17 cents as possible. And the Yanmar is one of the most efficient diesel engines that exist. This little guy here has a brake-specific fuel consumption, from everything I can read, that's actually a little bit lower than a Lister. I don't know in reality if that's how it is in the real world, but on paper, from everything I can read, this little guy, when she's loaded to about 70% of her capacity, or in other words, in this case, about 8 horsepower, which would be about 4,000 watts, she has a very, very low brake-specific fuel consumption. Hard to find anything lower than this. So we're going to see, we're going to be running some fuel consumption tests here next, and determine how close I can get to the cost of commercially produced electricity. I want to try and get close to 20 cents a kilowatt hour if possible. The other thing I'm going to do is I'm going to add another one of these alternators right here. I'm going to put it right here, and I'm going to run it off of this shiv so that I will have the ability to produce 5,000 watts. And I know the limit of this little engine already. The limit of this engine's about 4,000. She starts to blow black smoke out the exhaust. So I want, right now my limit is this one alternator will only put out about 60 amps at 48 volts, so 2,400, call it, watts. And I need to get a lot more than that to load that engine up to its 75-80%. So I'm going to add another Ford G1 alternator right here, and it's coming. I just found one online, and then we'll see what happens. We'll do some fuel tests. So it'll be interesting. Thanks for watching.